Anant, we're back.
Good afternoon, Ed. We don't do it this late typically, but I like West Coast. It's
That's
great.
true. Well,
It's
we're now the evening show for our large amount of East Coast
no no.
viewers. If
Absolutely, and you'll be surprised. Maybe they're just being polite to me, but uh, if you recall, there was time at Apogee when we would go to a customer and talk about something, especially Greg,
yeah,
and you to a degree, and we would kind of introduce ourselves, and they'd say, no, you don't have to. We've already watched your videos. So that's the experience I've had a few times. Maybe they were just being polite,
I
and
actually had somebody the other day who said I've watched your podcast, and I of course I almost burst into tears of happiness. I was like,
no,
oh
no,
my
exactly
god,
right. Okay,
yeah, yeah,
awesome. And I think it's this late in the afternoon because we want to keep our viewers guessing. And what's the
exactly.
sense in being predictable? Okay, so as always, we don't have to say lots happening. Lot is happening, but
Yes.
what stuck with you?
So I think there were a couple of different things that were interesting. You know, in the past week, well, we saw that. Uh, we saw, of course, some of the news with Airtable
Oh
and
yeah.
an acquisition
11,
around that.
11
And
billion to bending spoons. Bending spoons is somebody that I've started to hear about more recently,
well,
right?
they've actually. So I mean, they're one of the most prominent of really the SaaS consolidators,
Yes.
and so excuse me. With Airtable, look, Airtable is a great product, very, very well designed product. I think that said, it is one of the questions. Of course, people have gone and looked at this and used this as an example of, and just for context, the interesting part of the news is, they've been acquired and um, um, went through a very long history. The company's been around for a long time, as and lots of people have used it, but didn't quite, I think didn't quite exit at the range that people would have expected. And so the question really that people have asked is about, is it yet another indication of challenges to SaaS? And particularly at that level, the sort of no code application builder type of thing. And I without getting too much into the specifics, because I think there's a lot of other things going on when people talk about SaaS companies. Well, a lot of them have been around for a very long time, and so it may just be part of the life cycle of them. But there is something to be said for the fact that the types of ideas that one would have built out, or the types of applications that people one would have built out very quickly using these types of low code or no code platforms. There is some indication that those are not the direction that people would go these days when they can just use agentic coding to get there much quicker. So I think that's part of what one of the questions I think that made it most germane to this podcast, which was, is this an example of what was this causative by the sort of AI transformation in SaaS? And I have to, I don't know, it'd be great to get your take on it, but I have to think that it definitely has been, perhaps is perhaps part of the story.
No, no, I absolutely agree. I mean, Airtable, when I was doing my startup steps in, and we wanted to kind of produce some out of the box GraphQL APIs, one of the backends that we chose almost immediately was Airtable because it was just so easy to use, and we said that we could actually have our developers get a kind of free Airtable account to just see kind of the magic that we could do. So I've always loved it as a product, but obviously they have
Yeah.
shifted from look, we'll give you a very easy spreadsheet with much better APIs than, for example, what Google Sheets had, uh, that can be used collaboratively, to now the spreadsheet is the platform on which you build applications, right? So starting from that, right? So it's kind of a bit of a pivot, and I think you're absolutely right that that part of it is very much threatened with how easy it is to actually build anything.
Yeah, I think and so it's certainly an area, and again for both you and I, and for a lot of people who follow this podcast, tends to be people who are really at that intersection of tool building and
Yep.
operationalizing infrastructure and building applications. Just because it's the background you and I have had, and we're probably been very passionate and debated many of these things. Is one of going back to the early days
Of
of this
course.
stuff.
And so,
But
so other thing
yeah,
that's yeah, other thing that struck me is that how would you be a VC in this world given that things are changing so dramatically, right? And so
yeah,
because of that, over the last few days, as I have kind of read about Airtable, I've been reaching out to your VC friends and my VC friends, and
yeah.
we're going to have a couple of them come on our podcast because I think this whole thing about the sand is actually shifting underneath you. But then, how do you kind of build tenable companies? I think it's just going to be a very, very
I
fascinating
think
set of
it is
discussions,
it
and I
is
would love to.
fascinating. I think the other interesting piece of it, I've actually talked to a number of my friends who are sort of fellow founders of startups in the past,
Yes.
and in fact had the opportunity to spend some time with somebody who co-founded a startup with me. Um, about 15 years ago or so. It sounds about
Yeah,
right.
yeah, yeah, of course.
And what's interesting, and as much as it's hard for VCs, it's hard for founders, because I think one of the things that has been, I think, one of the truisms, for startups is that you end up doing a bunch of work, and you come up with this great idea, and you think it's a great idea, and then you go and assemble a team, and you spend 6 months going and working on that idea, and then typically you discover that that idea wasn't that great, um,
Yes, and you pivot,
and
and you
and
pivot.
and you end up pivoting, and what what's happening now is a lot of churning, because the time to the prototype, the time to the MVP becomes really quick. And so
Yes.
I've heard this now from a number of sort of colleagues, former founders who are trying to go and come up with new things, which is they get to their MVP in a weekend, and then they're like, oh, that sucks. And then they go and they try again and again. And so then I'm like, hey, how's it going? Have you,
We are on a fifth pivot. We are on a
we're on
fifth
we're
pivot.
we're on the fifth pivot, and what I actually think that part of the and so actually this one also I think is an interesting thing. As we do this, we should also we've had some of these conversations. Of course, we had Jonathan Ellis, co-founder of
Yes.
DataStax, here,
Yes.
and he had gone through some pivots on his stuff too. And
Yes.
part of it is that whole sort of form, storm, norm, perform thing, regardless of whether you actually build the MVP was important, but part of it was also working with building that team and that point of view and stuff. And that part AI can't speed run. So I do worry that the MVP churn, pivot, the rapid pivots is kind of messing with the heads of people. Like, it's better to have a bad idea and spend 6 months working towards it and thinking through a bunch of ideas than necessarily go through 20 ideas and not actually start to build
Exactly. You
those
get a
organizations.
lot of secondary benefits
Exactly.
of pizza and beer. Hey,
Exactly.
so look,
Anyway,
there are a couple of other things, but I'm looking at a clock, right? We are
yeah, we got
10
to get
minutes past the
started. So,
hour.
yeah.
So why don't we actually skip on that other set of things that we want to talk about? If there's time at the end, maybe we'll talk about it. But I want to actually kind of quickly jump in and get a guest in. So if it's okay with you, I'll introduce our guest,
Let's do it.
and let's get uh, uh, Hannah. Let's get Chi in. Chi is the EVP of software. In my mind, everything is software, even though at Cerebras, maybe everything is chips. But he's the EVP of software at Cerebras, which, for those of you who don't know, is actually fundamentally transforming the economics of post-training, kind of the inferencing world. And it's just really, really fascinating. You've seen small chips, but when you see what she puts up, your mind will be blown. But I've known him for now, I would say 23 years. Okay. And I have just really, really admired him, and he has gone on to do some really fascinating things that we'll kind of get into as we get into this discussion. The main topic is going to be about how is this world kind of post-training inferencing world, not necessarily dominated by GPUs or in particular by one company's GPUs, but we are going to get into a lot of what's the best practices to managing engineering teams and what are the lessons that remain with you as you kind of move jobs. So welcome, Chi. Okay,
Thank
awesome to
you.
have you on our podcast.
Yeah, thank you, Anant and Ed, for having me.
It's
Uh,
great to have you here. Yeah.
yeah, I would put up the chip. This is
Oh my
our,
Awesome.
God.
Oh my God. Oh my Condor
uh,
Galaxy.
yeah,
Oh my God.
it's a CS3 chip with 900,000 um, processing units, right, and have 44 gig memory on it. You know,
And and
um,
and and how much of money were you holding in your hand at retail price?
yeah, this is actually retail price very high. So yes. You
Okay,
can't get around
awesome.
the price, you know.
Yeah,
Okay,
yeah,
go
yeah. Of course, of course. Okay, Ed, go ahead. Let's fire away at
Yeah, well,
Chi.
let's jump right in there. I mean, I think that the interesting part here has been that, and which, you're thinking, and definitely in with Cerebras, what you guys have been the vanguards of is this pivot towards thinking about inference as essentially the new foundational unit of compute. And so this goal is to hear as much about that today, but would love to hear about sort of how you thought about this. You've come from a software background, but now you're thinking about this in terms of obviously for those of us in a software standpoint, we tend to think of the compute being a somewhat fixed substrate, but now you're sort of reinventing the compute for this new type of software. So love to get your thoughts on this as to kind of that trend and what this has meant, this trend towards inferencing as the center of the story.
well, thank you, Ed. Maybe just sort of walking through the like in sort of 2023ish, right? We have GPT. There's a past. Everyone was trying to do training. Everyone tried to fine tune the training, and training was the majority of the compute. However, I mean, it's kind of a not that hard to understand. Like there's a process of creation, there are processes that get used. Typically, the
Yes.
process of creation take 20% of money, and then process of use get 80%, right? Same thing for education. You take 10 years education, you do 40 years some productive work. But in the inferencing, what is really interesting is the first use case is really you ask a question, the thing comes back to you. Now the speed of the other side of the thoughts is as fast as you talk. So basically, all we do is create a more smarter human,
Yeah.
and then it actually is constrained by how fast you can type, how fast you can read, and then I think GPT, I guess O1 was the one really changed you called reasoning. Means you answer the question, but you also like start to reason, ask about it. Can you double check, right? And then that creates more demand on computing. And starting from that, you can see the inferencing really start to take off because the compute needs no longer constrained by the human. However, with reasoning, it's still constrained by human. Need to ask a question and check the answer. And then the agent, somewhere in the early 2025 is, am I got it right? No,
Yeah, yeah.
actually, late 2025, early
Yeah.
2026, it's just explosive, right? And I sort of see it. in my own eye to see. It's just like trajectory. In some way, it's also easy to understand because if you take out humanness, then the other side of intelligence have no constraint. They would just go ahead and solving a problem, and then what really happens, you start to see inferencing really take off, right? Jensen talked about 20%, 80%. I think it's about right. The other thing we're also seeing is
Oh, I'd heard of 50/50, that what you earn as salary is what you should spend on tokens. I didn't realize it's shifted to 20/80 now. Oh, you mean yeah, yeah, of
20%
course.
training, 80% inference.
Okay, yeah, yeah, of course.
And then
That's that. Yeah, maybe we'll add that one to the mix.
yeah,
Yes,
Yeah.
and then
2080 and 50/50.
yes, yes, 50/50 is like, okay, if one headcount costs 300K, you should spend 300K tokens, right? So
Yes.
they,
Yes.
but the interesting thing is, with inferencing, the entire compute also changes because in the training, essentially it's a batch computing. You essentially have data sets and then you sort of batch training. So it's really, and then the other thing is you have very small amount of people knows training and wield it. So you need to really
Yes.
have tools to do this.
By the
Inferencing,
way, what we are realizing is people who know training keep trying to form new companies, as Jeff Dean and Gemawat and others have proven just this week. Okay, keep going.
yeah. Okay. Anyway, long story short, inferencing is going to be the majority of the computing, and Cerebras is made for that, and I can tell a little bit more, but I'll stop here.
Fantastic. No, no, this is no, no, this is exactly no. Now, so the way let's talk a bit about how do you kind of before let's get into the Cerebras architecture anyway in a second. But the thing that I've always been kind of impressed with is how the chip providers who help with training try to lock the model architecture so that on the inferencing side, even if it's 80% of what it is, there's 20, so it's like 4x, it is still driven by their architecture, right? We know this, we know the kinds of things that they do. And so in addition to kind of not just talking about what is the optimal way of doing inferencing, you also have to kind of break that tie which says that no, I can actually run almost independent of how this model was actually built. So let's talk about both of those issues.
Yeah. This is a fascinating. Um, there's engineering side of stuff. There's also the economic and supply chain stuff, right? From the engineering
Yeah.
stuff, if you assume there's no overwhelming sort of dominant company, you start look at the problem. There's a training problem, which is a batch problem. You have data, you feed the thing, you have massive parallelism, you have a small amount of people reading it, and you have a small amount of company creating it. Okay, so that's one set. Another set is actually very different dynamics. You have everyone want to use it. You have a single API, OpenAI API. There are a bunch of
Yes.
models, and then what you really need to look into is what is the best way to run inferencing. And from that, if you really look at, and it's actually fascinating reading the original paper from Cerebras when they get funded. They basically said, okay, we can do the AI algorithm very well. Neural network, it's a layer, it's pushing forward, it never looked back. So they basically said, clearly it's going to be a memory problem and it's going to be data flow. So basically from that, I don't think the industry I think industry already converged. Basically the inferencing is sort of a data flow problem, and the memory is critical because the gen have to look at the past things, right? So, and that's the model you go after. Now, the interesting thing is there's, so from certain way, NVIDIA acquired Grok is basic validation, right? Because in some way, like if you look at NVIDIA, if you can just make sure the GPU can do both of them, why would you do a mix? This is very complicated, right? So in some way, it's just if from blank piece.
Now, just to be clear, they didn't acquire Grok. They acquired enough of Grok to
Okay,
not
okay,
actually
okay.
acquire
Yeah.
Grok.
So, but in some way, you can
Same
look.
difference.
Yeah,
Yeah.
it's actually easy to understand because if the transformer structure is reading the previous token and KB, QKB, then and the QKB very long, then you need a memory structure. And there isn't really much. If you do memory structure, there's DRAM, there's SRAM, right? There's huge difference. And then if you, so in some way, there's three things you can do really fast. One is you put compute and memory together. Two, you do a data flow thing, which is you always push forward, and that's what the network is. The third thing is you do sort of share nothing architecture, which is you.
My God, you're sounding like a database guy.
Yeah, it was a database. By the way,
Yes.
the interesting thing is when I so let me tell you a little story. So I was so first I was actually happily doing database, right? We're doing observe, because I think there's too many incidents. After I worked in Stripe, I feel like why there are so many incidents, there's nobody fixing it. So
Just for all of you,
go ahead.
Chi ran a huge part of Stripe's engineering, or perhaps all of it. And as you all know, Stripe is basically the operating system of payments for
Yes.
enterprise. And then he left and went to Observe because, yes.
Thank you. Yeah, so long story short. So Stripe, I was running Stripe payments. We need to do 39.5, right? And we process $1 trillion. And the most memory thing wasn't all the achievement. It was the number of incidents I have to deal with. And then it's more critical because you play with people's money. So after the Stripe mostly done, I was like, why no one can fix the incident stuff? So I run into Observe, which is essentially running the incident remediation and logs metrics on top of Snowflake, which is a database.
Yeah.
So I feel like database can solve everything. So I joined the company. We did 2 years pretty hard work and grow a lot, and we eventually joined Snowflake. So the company gets sold to Snowflake, and I'm looking for my next gig. Cerebras reached out, they a chip company. I was like, well, I think I'm pretty versatile. I'm not sure I'm gonna go drop all the way down to chips. So I talked to Sean, who's a super smart guy. So he started to show me, what they're doing in pipeline. I was like, hey, I know this thing. This look like ETL pipeline, plus this look like a database. And then we start talking about hash joining, sharding, memory machines, and top K, local aggregation, global aggregation. So I felt it's very interesting. So I just like joining. Yeah. So okay, so where are we on the on the NVIDIA thing? Okay, so if we from the pure technical point of view, you would say one is batch computing, high parallelism. The other one is push forward data flow. So we need two different chips, right?
Very good.
And that's what NVIDIA did. What we doing is we were like, okay, if you start from ground up, how would you then design a chip to solve that? That's what Cerebras thing is, because you basically put memory and chip into small dial, you connect all the dial together, and you can draw the region, each of the region become a layer of the network, and then you can flow those things through, right? So that's it. Okay, I think I talk about technical side. Now, commercial side, here's the interesting side. I think for quite a while, there was, so here's my observation. For quite a while, there are a lot of enterprise felt, I need to have a compute fleet can do both training and inferencing.
Because fine-tuning was the thing at that time.
Yes,
right?
because fine-tuning the thing all the time, and everyone felt like we think unless we inject our intelligence during the training phase, it will not reflect our intelligence, right? But the model is growing such to the point you basically can have a raw human brain, and then you can have separate schooling process. You don't need to mix it. Once that happens, everyone's like, oh, maybe we don't need to do training. All we need to do is doing the harness and doing the, the surrounding structure and data, that will be good enough. And then with all this agentic, all the things, so then a lot of people start to say, well, we maybe should just do inferencing. We can do better inferencing, right? So I think that also, I felt I mean, this is my guess, pushed NVIDIA a little bit to say, do you want to really, NVIDIA, okay, industry leading company,
Yes, yes,
to say,
yes.
should I really build this thing as an add-on to the training, or should I actually do it really all in, right? We were all in 10 years ago. Some company are all in 2 years ago. But
No,
that's my
yeah,
take. Okay.
of course. Awesome. Great discussion. And then, of course, your chip design itself is like regions and this and that. It's like an amazing thing. The kind of a dish-sized disk chip is like most amazing. We'll get into it. But Ed, uh, fire away.
Well, look, I think I think we actually jumped around to quite a bit there. Um, what does this look like as people are putting this thing to work? So zoom out for us in terms of how people are assembling these new types of systems. Because for example, I know you're doing some stuff with AMD as well, right? And so um, and I've heard this term disaggregated inference, which you touched some of the pieces on. But what does this practically look like? That help me understand that.
Got it, got it. So let's first talk about our own inferencing cloud, right? Basically, we have chips we put into chassis and have machines, and we have x86, and we form the cluster, and then we have OpenAI compatible API on top of your running models. Okay.
Right.
Now, when you do that,
So you basically, therefore, and either hyperscalers or enterprises roll it in their data centers.
there's actually our deployment model is two-faceted. One is we own a set of data centers. We will run
Okay.
these data centers, and we're
So
providing.
you're a neo cloud for Cerebras chips.
Yes, and then we also obviously sending the machines into people's cloud and superscalar. Like we had to deal with Amazon, we're going to put it into their data center, and they can run their model on top of it.
Right.
Now, in terms of if you really look at the inferencing problem, it's actually more nuanced. Basically, if you look at it, what happens is you give a prompt. The prompt have 1,000 words. The first phase is you basically generate, look up the prompt, and you don't do generation, right? It's a prompting phase. The prompt is called a prefill, which essentially just take every token and generate sort of attention, provide a KV cache for the attention. That's the first phase. This particular phase, because every word doesn't depend on other words, you would actually run in a massive parallel fashion, and it's very compute intensive. It doesn't really require a lot of memory access. The second phase, and then what happens is you produce these things, you store into the KV cache on the generation machine. The generation will read the thing and generate. When you generate, you always look up all the previous words word by word generating. So it's a much more sequential thing. Now, when you look at the thing, the better, so Cerebras will be super fast, right? We can do 10x, 20x token generation. But in terms of looking up existing token, get a QKV cache, that's a much more computing intensive thing that is actually very fit for GPU design. So one of the new thing is, what if we put together a hybrid cluster? You run all the, like you have a long sentence. You like, here's my article. Please summarize it. You give the entire article to the GPU side. You look up all the QKVs. When you generate first words, you sending all the QKV cache to us to Cerebras. We'll generate this thing for you. So the way you then do it is it's very general, right? You basically the coming you divide into two phases. Prefill phase sent to the GPU. Then QKV get typically through RDMA, whatever memory caching thing, copied to our machine. Then we run it. So now the best thing is the generation speed is still the same. However, the throughput is much higher because you do not need to take in the precious Cerebras resource to run prefill. You can run it on GPU, you can run an AMD GPU, and you can actually run it on Tanian.
Oh,
very cool.
And some special networking between AMD and you guys in their box or your box?
That's a
or
very
in the new box.
So the way it does is when you generate the QKVs, KVs, it's actually sitting in the HBM of the GPU, right?
Yeah.
Then that essentially what happens if you essentially get a copied to our chip,
Yes.
and there's some
Yes.
internal memory. So the way is we just use networking. Like actually IBM invented this thing. It's called RDMA.
Yeah, of course.
Ah, yes.
Remote data management access. I forgot that thing, but
Yeah,
basically
of course.
copy really fast. So they copy the memory to our side of memory, and then our side of memory we can look it up. That's basically what.
What you and I, Ed, would know as memcopy,
Yeah,
Yes. Yes.
RDM.
right?
It's
But
IBM invention.
yeah,
Can I say some proud words about IBM, right? So
yes, uh,
very respected company in Google. We were doing all that stuff, and there's day someone said, "Gee, we have this new thing, and it's really fast." And then they showed me the paper. I was like, "You talk about remote memory copy, right?" They're like, "Yeah."
mm,
I
of course.
was like,
No,
"That's
no. Hey,
IBM thing, right?" They're like, "Yes, yes, yes,
it's a
yes, yes."
separate story. One of the best ways that I managed to piss off somebody at Google is I said, "Oh, MapReduce is really just parallel shuffle that we used to do in databases,"
Yes.
and
Heresy.
so it's, yeah, heresy, absolutely.
Yes.
Okay, no, this is really fascinating. So what I think this is something, Ed, if you recall when we had the conversations on quantum, which is slightly different than this, there is a belief that the future of workloads is kind of a multi-architectural future. You'll have CPUs. Within CPUs, you could have an AMD Intel style or an ARM style. Now we are hearing you can have multiple GPUs. You can have GPU and you can have Cerebras, and then you can have, for some cases, you can have a quantum processing unit, right? And it is not that workload X goes there or workload Y goes there, but workload X itself may decide to use different things as Chi is pointing out. So this, I think, is a really, really interesting evolution of architecture, and this is a good microcosm of that.
Exactly. Yes. I mean, that is the super interesting. So is that's essentially what you're saying there? She is that we are seeing this sort of materialization of a new hardware architecture for bringing these in. The sort of a multi-compute architecture between different forms of GPUs, inference systems, and so on. That what does that mean from a software standpoint? Like, is that do existing software tools get people there? How do we build for this world?
That's a good question. I'm trying to think about what we analogy. But the way is there's obviously the same thing, right? And now we have done this thing before. When first, if you heterogeneous, then you would first have software. Obviously, there are VRM, SGLAM. They're working on the GPU side, and there's sort of a our own proprietary software working on our stuff, and then in the middle you connect, right? And then there are routers sitting on top of it. There are a lot of disaggregated inference company doing that, and so that's the first thing, federation. The second thing is actually a lot of software vendor will say, you know what? I actually can create a software lag on each of the chips, so I can do that. There's also software vendors start to say we will generate code can run on different chip architecture.
Yes, that's what I'm.
Yeah.
That's interesting. Let me just kind of generate the code for some specific architecture.
Yes, yes, yes. And there was quite a lot of company doing that. They would essentially try to understand it almost look at different chip as a one giant machine, and they think about like, okay, how do I coordinate it? How many things I need to send to the left side? How many things I need to send on the right side? And there's trade-off, right? For example, if the prompt is very small, should I just generate it on the service instead? All that kind of thing. I think it's a fascinating. My view is I think we each of the chips should really optimize their thing, right? So we need to do a very good job. The second thing is obviously the software we have. We do need to make the SDK or make the open source whatnot, and to make sure people can use this thing. Because at the end of the day, we're producing machines. If we have more ecosystem using us, that's better.
Exactly right.
Yeah. But we are working with various vendors, right? We're like very open to working with everyone. Okay, if you run on Cerebras, that would be great. How can I help? Yeah.
This is absolutely fascinating. No, this is we have, and then Do you run into some similar, again, we don't have to get into kind of
Yeah.
the internals, but I mean, everybody talks a bit about kind of all the constraints in hardware that kind of give a lot of, so I mean, I follow both Dylan Patel and Dwarkesh Patel. I don't know whether you do, but they are really, really fascinating ones. And Dwarkesh just had one podcast on kind of the, if compute is only increasing this much, how can Anthropics and others get 10x revenue? And therefore, they really boil down to there's a lot of pricing power in the compute level because of all the constraints and all that stuff. So, so does it help to have kind of multiple architectures to kind of get over this swamp of constraints, or in the end you end up with similar constraints of ASML and TSMCs?
Uh, let me try to think about how to answer. I think it is a question whether where the hardware's constraint is.
Yes, yes. That's what I'm asking. Is it's a very different architecture than GPU,
Yeah.
right? And we talked about how it can be used because one is a data flow and one is
Yes.
parallel
Yes. Yes.
matrix computation,
Yes.
right? So it's very, very different, right? We get it. And but does it in the end, right, that architecture, even though it's more optimal, runs into similar constraints because the world is all constrained around how fast hardware can be compute can be manufactured.
Oh, I see. I see. That's a great question. First of all, we uh, obviously there's only a few companies in the world can manufacture chips, right?
Yes, yes,
I think uh, right now we're in a very supply constrained environment. In a
yes,
supply constrained environment, this is one thing I learned is vertical integration is actually a good thing because
yes.
practically you can't really control all that thing, so you have to vertically integrate it. With the vertical integrated, and that's where some industry leading companies, I will not name it, they are actually really actively acquire the supply thing like HBM. Let's actually be very very clear. In the chip layer, there are two major constraints. One is the chips, how do you print the chips and how do you packaging. That's actually very constrained, but we have a very good relationship with the leading vendors. We're all good. The other thing that everyone else, like NeoCloud and chip companies, is constrained HBM.
Right.
HBM is being pre-bought by NVIDIA, okay, leading companies. We're actually very lucky because we do not need HBM. So
Exactly, exactly.
we
Exactly.
Okay.
actually, Andrew said many times the fact we don't need HBM, we can print the memory ourselves, is actually relieve us from this. Like the price increase on memory, we actually don't need to be constrained on that.
And
Yes.
that's the angle that I wanted to kind of get
There
to,
we go.
right?
Okay. Yes.
It's so it's not just different architectures, which is just awesome, okay? Which, as a technical sense, makes sense, right? The right architecture for the right job, and the job post training is different than the job in training. But also the kind of the constraints and kind of the pricing things, right, are different. And that's why, for example, I mean, it's not that you guys will compare yourself with Samba Novas and others, but there are other people trying kind of different architectures on
Yeah,
the
you're spot on. In fact, there's a
on
period of time, there's a lot of chip company, right? We're obviously leading on that thing, but we actually heard a lot of chip company, but they sort of depending on HBM. And then when the HBM really run short in terms of increasing pricing, decrease supply, there were some difficult people running to. I think we were, because our architecture and not depending on these supplies, we definitely have a good advantage. Yeah.
How much do
awesome.
you have to how much do you have to create your own sort of forks or versions of the model architectures specifically for your hardware? Just
That's a very good question. I think just think about it's almost like if the model architecture is like a database query, all that stuff, right? We're very general. We can take a PyTorch. We can take PyTorch version. We can run it. We can run all the open model, and then we will work with OpenAI. There's actually no modification to their model. In fact, these model company are very very focused on like nobody touched their thing, because if the quality has a problem, is your problem or their problem. So we have to
Okay.
stay authentic. We're just like computing execution now. The binary code, when you compare to Linux versus when you compare to some microsystem,
Obviously, that's
and
yeah.
I'm not saying we're some microsystem, but the code we have is almost
I
like
hope
you
not.
come on Spark very
Yes.
well, right? So we
Yeah.
actually have a lot of work to look at the model and generate the assembly code running on top of us, and then do this thing very efficiently. Yeah, and that's actually a big part of the software group is doing that.
Okay.
Awesome.
And then,
Hey, listen,
okay.
we're going to run out of time.
Oops.
So I had
Yeah.
a blog. Put aside Stripe and put aside Observe and put aside Google and IBM and now Cerebras and all the fascinating things that are going on there, and you're helping out. But you have talked a lot about what does it mean to actually run big teams, okay? And you've described yourself, I think, as an impatient technologist who cares about people, or some such word like that. I
Yes.
wish I were as famous as you. I'd also describe myself in some way. No, but tell us a bit about how do you go from being an army of one, okay, to an army of hundreds of thousands.
Yeah, that's a great question. I'm very fortunate to start with a very large company, right? So we start with a small company. You got acquired as Rhetoric, and I learned a lot of stuff from IBM. One of the things I would have to say is when I went to Google, everyone's like, all the stuff you learn from IBM, it's like
Forget
very
about
old
it.
school, whatever. You turn out when you see Google grow, they're like, and I started reading some trick to people. Everyone's like, this is great. Where did you learn this? I was like, from IBM. What do you mean? So what I actually learned is we always like saying, oh, this Google is dinosaur now, right? IBM's dinosaur, whatever they learn. What actually really happened is in different stages of the company, you have a different organization to solve this problem. So when we look at other people saying their org structure is kind of terrible, it was not because of that. It's because their business model, their stage, right? So one thing I actually learned is to say, different from what the manager book tells you, the organization is created to get stuff done. So once you remember that, then it's actually very important to think about what was today's problem. Was their organization changed to solve that problem, right? So there are a few tips I would say. One thing I noticed is people are very hung up on stable organization. Here's the thing I created. How do I scale? The interesting thing is every organization is solving the scale of the organization at the time when you create an organization. If you're really, really fast growth, then you have to reshape your organization. You want to do it very quickly. And then I don't think a lot of people, first of all, think it's a positive thing. Everyone's like, always keep on changing. It's a very flux. And one thing I absolutely learned from Stripe is that is okay. In fact, that was a good thing. And then I'm trying to like communicate to everyone, say, guys, if you keep on changing or keep on changing the thing to fit your business model, that means you grow really fast. Okay, just be cherished. So that's actually number one. By the way, this is actually by far is the most useful insight when I go to a new company. Because everyone
So
like,
org change is not necessarily is typically people think you're changing orgs because something is not working. You're saying something is working, but a different thing needs to work at the next stage.
exactly. I thank you very much. You said it so well. So and then the way is you don't need to change for the change, right? You every time you do an org, you start to think about, and this is actually we learned from Stripe. You start about 18 months. What the business look like? How do I create an org that it will be very efficient, and you iterate towards it. Now, and then there's nothing bad about it. In fact, the only way you measure success for the org is whether you scale to it. So that's actually very interesting because I actually find a lot of people intellectually disliked org change, but to be fair, the org is just a way you put a bunch of people together to achieve a thing. So if the thing you try to achieve changes, you must change. So that's number one. I actually find it was a very common sense, but probably the number one thing people felt is very insightful because I told them like, look, I went to IBM, to Google, to Stripe, and all sorts of companies. I'm telling you, like the thing you had in the brand that is very static org, very orderly knife, right? Doesn't exist.
But
So
the term is org, which means organized, right? And
yes,
and you are saying that it should be the opposite of that.
yes, yes. So I wrote a paper called a wartime manager because everyone was like,
Yeah, 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 yeah.
well,
I
so
I don't like
I
that term.
feel
I
free
don't like that
to
term.
feel free to look at the blog. So that's one inside. How many minutes I have? 2 minutes.
No,
I
please,
should.
no, go ahead, go ahead. No, no,
Go
as
ahead,
many
keep
as you
going.
want.
We can go.
We
The
are
Yes.
other
fascinated.
thing that is actually very interesting, in Google or different places, I think what people also learn is like once you did a creation, you're successful, right? You are attributing a lot of success to how you do things, and you completely forgot it was a marketing dynamics. It create that. So we all be successful, but everyone think we can recreate the success because we're the same set of people. But the issue was not that. Is actually the innovation need to be very specific. One big thing I learned is um, when you're doing engineering work to scale, deliver a large project, it's completely different from innovation. If you do innovation, you have to have a team smaller than 10, maybe 8, have a space, they do it. No matter how big your company is, the innovation start with 10 people or 8 people. I do
Yes.
see, I'm not going to name company. Every time when they like, guys, we need to double down X. Let's give it a budget of 1,000 people. Okay, that's a sure way you kill a project, right? And Google did the Google Plus. We put so many
Yeah, yeah.
people on it. Honestly, you just
Uh,
need
Yeah.
to 5 people to get it working. Okay, so that's
yeah,
the next event I have. Yes.
yeah.
Yes. Innovation and mobilization are two different things. Yeah.
My God,
Exactly. One
Yeah.
of
you
the things
guys are
then
like,
it's very specific we do is now in Cerebras when we try to do AI, I basically peel aside a team, right? I was like, okay, you gotta have 4 people, you can do innovation, you will not do OKR, you could do the same. Okay. I I'm not gonna put any order on you, but you can do innovation. It's very separate from I have 500 people, I'm all gonna do deliverable. All right. For that thing, we're like organized army, right? We're gonna attack it. Okay.
Yep.
no, and the reason I'm smiling is, gee, that's a little bit of what we tried to do when we were doing that mini ETL project, right?
Yes. Yes.
Uh, uh, Eons back. Hey, listen, this is absolutely fascinating. Ed, any last questions? I mean, we could go on and
I know. I
on.
mean, every question I ask would be. I mean, this is awesome. Every question I want to ask, we would go on for another 20 minutes on. I think very much appreciate having you on, and maybe we'll have to do a part two
Oh, we
on
will have
this.
to do.
Yeah.
Yeah, yeah, we'll have to do it. I'll have to try Cerebras Cloud. But
Thank you.
here's what I'm thinking, Ed. There was one topic that I didn't cover in a pre thing. Why
Yes.
not have that conversation with Chi here? Okay, so Chi, uh, as you know, in the pre-segment before you, we talk a bit about some of the latest news items, and I wanted to kind of get your view on whether this thing smells right for your large organization or not, right? So you would have heard of Lenny Rechitsky. He's a fantastic, very even-keeled
Yes.
podcaster,
I,
right?
yes.
Yeah.
Right? And he and Noam Siegel have recently come out with a sentiment survey about how AI is impacting tech workers.
Oh, cool.
And it's a survey of 6,000 people. I don't know how scientific it is, but I'm assuming that it's pretty scientific. And two things kind of uh, stuck with me. One was Ed. You may not have read it, but one was that the amount of negative sentiment, negative to be measured in terms of look, things are not going to turn out okay for me personally, kind of thing, had risen a few points from last year. But more importantly, the world was, they talk about four types, but the world was either people who were saying, come, bring it on, right? We are having a time of our lives, okay? And the second one saying, look, we are overworked and getting burnt out, right?
Yeah.
And
I
so
did see that.
from a,
Yes. Yes.
right? And so from your kind of organizational perspective, what is it that you're seeing with respect to AI? I know you're building stuff for AI, but AI impacting people who are writing software or building products. What is it that you're seeing? Is it optimism? Is it pessimism? Is it overburdening? Is it a mixture of all? What's your view on that survey? Even though I just kind of just threw some numbers
Yeah.
out to you.
Well, I'm busy building chips and haven't read the survey, but this is actually a common talk of the AI world, right? And I'm more in the optimistic view side. Although the way I would zoom out is, I don't think. First of all, we should look at not now, right? But if you look at zoom out for 50 or 100 years, having AI essentially means have so many brands that can sync in action and connect together, and this is going to advance human health, right? And so, okay, if we run out of working in the earth, fine, go to the solar system, you go to the universe, and there's trillion of the things, so you have infinite amount of work. I don't think in the long term anyone like really worry about it. I
Unless
think
unless AI kills you, which is
That,
another
that's yeah,
another
that's true.
which
But
yeah.
the way is the way things that do you want to control the trend, or do you want to? Because even we don't advance it, someone else is going to invent the thing that we might be in trouble, right?
Yeah.
So, and then in the short term, what I see, okay, zoom in a little bit. Obviously, if you're a software engineer, if you're a software organization, the first thing is need to be very practical. Means put aside all this. The people you are compete with, the people you are serving, the people serving you, they're like it's really fast. We all heard, I the people I heard talked with, I respect. They're not doing classic coding anymore, right? And they're just iterate and other things. I think what happened is there's small amount of people already know how to do this. They're enjoying it. They have super productive. However, the mental strain on them as type of work is actually very taxing because this thing is so powerful. It's almost like it's okay when you drive a car at 80 miles, but if you always drive a car at 200 miles, yes, this is great, but it was very tiring. So that's one. I think the work will change. We have to figure out how do we make sure you don't always drive the 200 miles car like 24/7, right? So that's one set. The other thing is basically more like it's not comfortable. Even it's powerful, it's not comfortable. I don't want to do it. There's always that, right? So you can bike to a places, you can drive to a car. The drive car is better, but people just feel not comfortable. I think that's more
Yeah,
education.
that's because Ed is driving on the road and it's dangerous for them. So they
Well,
want.
I use, of course, I use the self-driving car, but I think it goes to that same point, which is that if you're driving your self-driving car at 200 miles an
200
hour
and
and and it's telling you keep your hands on the wheel at all times because you got to be prepared to take over. That is very taxing.
that's very
Exactly.
But yes.
Exactly. Exactly. So we were basically in the similar stage, right? There's people who, a small enough 10% people who really enjoy the thing, the productivity is 10x, right? And then there's
Yeah.
people who are like, this is scary. I want to learn a little bit, but they are learning, right? And then there's certain folks who are like, this is terrible. And then I think every technology is like that. You take like 10 years and everyone just get used to it, right? Same thing happened with mobile. So I'm not too worried. I actually feel what we as a software manager or leadership need to do is actually anticipate the three different types and make sure how do you minimum the downside and increase the upside. So
Exactly. No, exactly. The point is not so much on look. We can't say you don't get it. It's really really awesome, right? People have to internalize it, right? And they have to kind of feel it, right? So that's the thing that I got out of it is because you and I and Ed and many others that we hang around with are kind of full of enthusiasm. My God, look at what we can do now that we couldn't do before. And it's very difficult to kind of understand why wouldn't you see it? But the fact of the matter is that 3,000 out of the 6,000 people didn't see it, right? So
Yeah.
it is just something for us to kind of internalize and create the right structure so that people, a large fraction of them, kind of get to that happy place, right? As opposed to they get left behind.
Yes, yes.
Yeah.
There need to be, obviously, I'm not a policy guy, right? But there was, because whenever you get a very efficient, it does create bipolar of the wealth and power. So you kind of need to take the society with it, because otherwise you're going to create problem. I think
Yeah, yeah,
that's
which is
where,
which is which
yeah.
is what's
Yeah.
happening with the data center debate. Okay, we are delving into a bit more
We could
of
definitely go for a long period on that one,
lot.
but I actually do think a lot of these things will self-correct themselves, unless, of course, Cerebras makes the price of inference so low that it accelerates AI. Then perhaps we need to solve those questions sooner. So uh,
Or,
Thank you.
maybe it's
which is
directly related.
okay. This is hey, Chi again. Thank you very much. Uh, we'll wish you goodbye, and then Ed and I will close with some thoughts.
Thank you very
Okay.
much. Thank you for having me.
It's good.
Bye.
Great to see you. Yeah, so that was fascinating. I mean, so many deep topics, and and of course, in talking with Shit, it bridged because he's a software guy who's gone deep into hardware, and you and I, of course, are trying to learn more about these things. But he's had a lot of great thoughts about this, and I in particular, I could have gone on. I really wanted to hear more about this memory architecture.
Let's
That
let's let's
was,
let's
yeah,
let's get him again beginning of next year, or
yeah, I think so.
even later this year, right?
Yeah,
We've got, but he's just he's he's and we have met quite a few on our podcast, people who are kind of brilliant engineers on their own, but are able
yeah.
to kind of affect organizations, right? Because that's what really matters. So that's just an absolutely fascinating conversation. Okay, awesome. So next time we are going to get J.R. Rao, who's an IBM fellow and head of security research at IBM, and we all know that it's good to inference fast, but if the bad guys are inferencing fast, okay, on the piece of software that I've written, and I'm exposing my mm, enterprise knowledge on, then bad things can happen, right? And so we're just going to get into some really, really interesting conversations on whether the frontier between the defenders and the attackers is actually changing, and where do these economics really work with JR
I
next
think
time.
it's gonna be fantastic. Is he's got very deep into AI research, as other parts of the things that he's done, and so I think, as we all know, like, now we know. I don't think a year ago actually was as much on people's radar screens, but obviously at this point we now know that AI has changed everything from a security standpoint, completely the nature of the attacks and defense. So it'd be great to catch up with him on
It will
that.
be absolutely fascinating. Okay, awesome, Ed. Thank you very much, and
Thanks for all of our
see,
members of our audience who are
okay,
watching us, assuming they're watching live at a later
yes,
date, at a later time.
and then of course we want to thank Hannah, Milan,
Yes,
and Michelle who couldn't make it
Michelle.
today for making us look good.
Making us look good, making sure that all the prep that goes into this, we it doesn't look, it may not make it look like we do, but it actually takes a lot to pull this together. So we're very appreciative.
At least one fifth of the segment is unplanned, right? And so
I
that's the
think this
risk.
one was way more than 1/5, and in fact,
No, 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 no,
we're
no, no.
proving that in our wrap up right now.
Okay. Hey, thank you very